So now's the right time to make another video. Hi Celeste, I know you're getting ready to come down here. Really excited about that. The location for fusion reactions. I've been watching a lot of Pierre-Marie Robitaille's talks about the lattice sun model. And as well, I've been looking a lot at mainstream's interpretations of where fusion occurs and what happens, what's required to make the nuclei of atoms come together to make and combine to make a fusion reaction, where the two lighter elements combine together to make a heavier one and release a tremendous amount of energy. Tremendous. That process happens not in stars. The fusion process happens in active galactic nuclei. The idea that stars make elements is a 1930s, 1940s worldview. Stars are incredibly energetic, yes, they are. But before the 1930s, 1940s, they really didn't have much to go from in astronomy. They didn't have as advanced enough telescopes, and the telescopes they had didn't view in many different frequencies. That being said, the frequencies that we needed to have in order to correctly hypothesize where fusion reactions take place was in the radio frequencies, the radio waves. And we took pictures of these birthing galaxies that are making new spiral arms inside the radio frequencies. The radio frequencies are really long waves, so they won't be visible. When you see this picture of Hercules A, which is a birthing galaxy, undergoing the fusion processes where it accelerates material and it slams into other material fast enough to overcome the Coulomb barrier, which is the electrostatic barrier between two positively charged nuclei. The amount of energy required to overcome that Coulomb barrier exists inside of these jets, and that's what's happening right here. Is you're seeing a lot of new material being created, new matter being created. But anyways, take this part off and take this part off, kind of like look at it like that. That's what's observed in a visible telescope. That's what early astronomers used to look at, and they said, oh, it's just a big blob, nothing interesting happening there, the elliptical galaxies. And then, fast forward into the future, we get a different picture because we can actually see what's going on in radio frequencies. Now, these birthing galaxies are not accepted by the dogmatists that work inside of academia and universities these days, because to them all galaxies are created from the Big Bang, and what you see is what you get. They don't realize that newborn galaxies are born all over the universe right now, and the telltale signal for a birthing galaxy is these bipolar outflows. So like a double-ended sprinkler, and these obviously are going to start morphing, and you're going to get the spirals out of them. So I think I went over that in an earlier video that Baz made me a few years ago. Baz, we've been at this for a couple of years now. That being said, the location for fusion reactions, I know that stars don't fuse matter together because they're not energetic enough. Even this has been known for some time. Some early astronomers did some calculations about how much energy even 20 million Celsius would produce. And 20 million Celsius, which is the theoretical interior energy or temperature of the sun, is only about 3,500 electron volts. And you just plug in a simple numerator denominator, say 20 million Celsius is only 3,500 electron volts, and you need millions of electron volts to fuse matter. And that would mean that the total temperature of the sun would need to be over 5.7 billion Celsius. It's far, far too hot for the fusion process to take place inside of any stellar interior. Stars are thermochemical and electrochemical and mechanical and magnetohydrodynamic, meaning magnetic fields and moving fluids are the driving processes behind the stars. The stars aren't fusion reactors. The fusion process, not only that, is an open system. We know it's an open system because we observe it as an open system. So the idea that this is supposed to be a closed body, which, has led a lot of theorists and academics to think that, oh, well, we're going to make a fusion reactor inside of a box. And we're going to get the box really, really hot inside, and then fusion reactions are going to take place. They're doing the thermodynamic equivalent of stirring a hot cup of coffee with a spoon. You're not going to get more energy out of that than you put in, because fusion is an open process. You need to have material exit wherever it is you're working with, because the amount of energy required to trap that much material in an enclosed container and then maintain that amount of energy is just too high. 5.7 billion Celsius is far too high for any real container to have it enclosed. And in order to get over that, because temperature is the same thing as basically saying kinetic energy, what you do is you just accelerate particles at extreme velocities. And of course, the Large Hadron Collider is fusing matter too. That's what that does as well. But those extreme velocities are what we required. Of course, also in large amounts too. I mean, you're looking at tens of thousands of light years in diameter here. This is not a small object. It's not something you can necessarily put in your pocket, like I do with this picture. But and I have that written in the book. I'll link the book to the bottom, page 63 to 65. The high energy galaxy jets are what allow for fusion processes to take place, not inside of stars. The stars, they come after the fact, as the galaxy is being born, and then the material sorts itself out later, creating the stars, which are electrothermal and chemical in nature. That's what stars are. They're not fusion at all. I'll go ahead and read this out to you, because I think it's a good statement. I think I said it pretty clearly in this paragraph here. Astrophysicists born in the late 19th century, such as Eddington, Atkinson, and Heutermans, took their students on the wrong path of discovery concerning the location of nuclear transformations. The correction in observations is as follows. Stars are electrochemical, thermochemical reaction chambers and are actively engaged in vast chemical exothermic reactions, meaning the chemistry that's occurring inside of a star is what's creating the heat, but it's high energy chemistry. Nuclear physics is negligible. The existence of radio galaxies were not known in Eddington's time, nor were the relativistic jets that create all the matter necessary for star formation. Meanwhile, mainstream scientists believe quasars, pulsars, and other types of high-energy objects rely on strange matter and exotic theoretical ideas which have no basis in reality. That includes the nonsense of black holes and dark matter and all that. What is more appropriate is to place stars in the arena of chemists and those who study rocks and minerals, and redirect the processes of nuclear transformations where the energies and velocities are high enough for them to occur, and birthing and active galaxies. If this is not done, then there will be a great waste of resources chasing the fusion process. And that basically sums it up. That's why I'm talking about that in particular. There's going to be a lot of wasted money trying to chase the fusion process, but it all comes down to worldview. If you have a worldview that's misguided, as do a lot of astronomers, the vast majority of them, you're not going to be on the right path. It's taking a road that has a dead end, and what happens is these astronomers, they go down this dead end road, and then they, collect all together, and then they just groupthink themselves into perpetual denial that the observations are telling them something completely opposite of what's true about the world around us. Anyways, I think that talks way long enough. All right, later.